Hello guys and welcome to our YouTube channel. In this video we are going to solve a question on systems of equations. Okay, so the question says given the matrix A, where A is that matrix, find A the determinant of the matrix A and B the inverse of the matrix A, hence or otherwise solve the system of equations. So these are three equations. Okay, so let's start with the first part. So we have solution. So let's start with the first, with A. A says we should find the determinant of the matrix A. So let me just write back the matrix, which is 2 1 2, 3 1 2, and 2 2 1. Okay, so to find the determinant of this matrix, we do cofactor expansion. So let's find our row. So I'm going to choose the first row to carry out the expansion. So I put my plus minus plus, minus plus minus plus minus plus to tell me which element will have which sign. So we start with the first element, which is plus 2 times. Now we eliminate its rows and columns. Eliminate the row, eliminate the column. We are left with 1 2 2 1. So we have 1 2 2 1. We take the next, which is 1. It has a minus sign, times. We do the same thing. We eliminate its rows and eliminate its columns. We are left with 3 2 2 1. Now we take the next number, which is 2. It has a positive sign, times. We delete its rows and columns. We delete the column, delete the row. We are left with 3 1 2 2. Okay, so now we simplify. So we have positive 2 now times. So this is a 2 by 2 matrix, so we look for the determinant. The determinant is 1 times 1 minus 2 times 2 minus 1. Take the determinant again, 1 times 3 minus 2 times 2. Take the determinant again of the next, 2 times 3 minus 2 times 1. So now we simplify. 2 into 1 times 1 is 1, minus 2 times 2, which is 4. We have minus 1 into 1 times 3, which is 3, minus 2 times 2, which is 4. The next, plus 2. 2 times 3 is 6, minus 2 times 1, which is 2. So now we have 2 into 1 minus 4. 1 minus 4 is minus 3. Then we have minus 1. 3 minus 4 is minus 1, plus 2. 6 minus 2 is 4. 2 times minus 3 is minus 6. Minus 1 times minus 1 plus 1. 2 times 4, 8. So we have minus 6 plus 9. This gives us 3. So we can say that our determinant of A is equal to 3. Now we'll go to the B part. The B part says we should find the inverse of A, hence or otherwise solve the system of equations. So first we need to find the inverse of A. So the inverse of A. So the first thing we do is we write our formula. So A inverse is 1 over the determinant of A times the adjoint of A. Okay, so we know the determinant of A, we solved it above. Now the only thing left is the adjoint of A. So now we need to look for the adjoint of A. So to look for the adjoint of A, we need to use the cofactor method. We need to find the cofactor matrix and find its transpose. So the adjoint of A is equal to the transpose of the cofactor matrix. So now let's find the cofactor matrix. So we take our original matrix and write it down 4 times. Now we eliminate the outer numbers and we are left with 1 2 3 1 2 1 2 2 1 2 2 1 1 2 3 1. Okay, so now we evaluate. We are taking it matrix 2 by 2 matrices, so matrix by matrix, to give us each element. So we have our big bracket. So we take the first 2 by 2 matrix, 1 times 1 minus 2 times 2. We take the second 2 times 2 minus 1 times 3. We take the third 2 times 3 minus 2 times 1. We take the next 2 times 2 minus 1 times 1. We take the next again 2 times 1 minus 2 times 2. We take the next 2 times 1 minus 2 times 2. We take the next 2 times 1 minus 2 times 1. We take the next 2 times 3 minus 2 times 2. And we take the last 2 times 1 minus 1 times 3. So now we simplify to get each element. 1 times 1, 1 minus 4, 4 minus 3, 6 minus 2, 4 minus 1, 2 minus 4, 2 minus 4, 2 minus 2, 6 minus 4, and 2 minus 3. Okay, so 1 minus 4 is minus 3. 4 minus 3 is 1. 6 minus 2 is 4. 4 minus 1 is 3. 2 minus 4 is minus 2. 2 minus 4 minus 2 again. 2 minus 2 is 0. 6 minus 4 is 2. and 2 minus 3 is minus 1. Now this is the cofactor matrix. So remember from here, the adjoint of A is the transpose of the cofactor matrix. So now we can say that the adjoint of A is the transpose of that matrix. So we take the transpose. So finally, the adjoint is, now the rows becomes the column. So the first row becomes the first column. The second row becomes the second column. And the third row becomes the third column. And that is the adjoint of the matrix. So we are not here to find the adjoint, we are here to find the inverse of the matrix. So we put everything back in our formula. So A inverse is 1 on the determinant. The determinant we had was 3 times the adjoint, which is minus 3, 3, 0, 1, minus 2, 2, 4, minus 2, minus 1. So if we are to simplify that, we are going to have minus 1 here, 1, 0, 1 on 3, minus 2 on 3, 2 on 3, 4 on 3, minus 2 on 3, and minus 1/3. So this is what we have. So this is the inverse. But that is not all. The equation further says we should solve the system of equations. So let me just write back the system of equations. So we have 2x plus y plus 2z equal to 3, 3x plus y plus 2z equal to 3, and 2x plus 2y plus z equal to 2. Okay, so the first thing here, we are to solve a system of equations. So the first thing we do here is we write it in matrix form. So we are going to have 2, 1, 2, 3, 1, 2, 2, 2, 1. Now all that times x, y, z equal to 3, 3, 2. So that is what we have. But okay, to solve this system of equations, they are just telling us to find the values of x, y, and z. And to find these values of x, y, and z, we simply take that. It's going to be this times. So we are going to take the inverse of this matrix, 2, 1, 2, 3, 1, 2, 2, 2, 1. So it's going to be the inverse of this matrix times 3, 3, 2. So this is what we have. So now we have to find the inverse of this matrix, but we found it above. If you look, this matrix that we have is the same as the matrix above, the matrix A. It is the same as this matrix A. So they are the same. So we have already found the inverse. So now we just substitute it and solve. So this was the inverse of that. So we just substitute it and solve. So the inverse now of this is 1/3 into minus 3, 3, 0, 1, minus 2, 2, 4 minus 2 minus 1. So I can take only this. If I take this, it's going to complicate things for me. So since I don't want to deal with the fraction now, I'm going to multiply this inverse by 3, 3, 2 first before I add the fraction, before I include the fraction. So let's multiply those two matrices. So I'm going to have 1/3 times. So remember, we are multiplying rows by columns. So we have minus 3 times 3 plus 3 times 3 plus 0 times 2. That's our first element. 1 times 3 plus 3 times minus 2 plus 2 times 2. Second, 3 times 4 plus 3 times minus 2 plus 2 times minus 1. And this is our 3 elements. So we have 1/3. Now we simplify this. So minus 3 times 3 is minus 9, plus 3 times 3, 9, plus 0 times 2 is 0. We have 1 times 3 is 3, plus 3 times minus 2, which is minus 6, plus 4. 3 times 4, 12, minus 6, minus 2. So we still have the 1/3. Minus 9 plus 9 is 0. 3 minus 6 is minus 3 plus 4. Now we have 12 minus 6, which is 6 minus 2. So we simplify again. So I'm just simplifying step by step to make things easier for me. So we have 0. Now we have minus 3 plus 4, which is 1. And we have 6 minus 2, which is 4. So remember, we are looking for x, y, and z. So we include our 1/3. Now we multiply everything by the 1/3. So we have 0, 1/3, and 4 on 3. So therefore, our x is 0, our y is 1/3, and our z is 4 on 3. And that is all for the question. So that's all for today, guys. Thanks for watching this video, and I'll see you guys in the next video.